This video covers Reporting Category 1, Day 2. In Reporting Category 1, as we saw on Day 1, there's factoring involved. Day 2, what we're looking at today, or in this video, is factoring special cases. So on Day 1, we reminded you how to factor with the box, and then today, or in this video, we're reminding you how to factor special cases. Now, some of these special cases have formulas on the formula chart. If it is a perfect square trinomial, or if it is a difference of squares, it will be set up like what is listed on the left and can be simplified quickly to what is listed on the right side. So one of the perfect square trinomials has been done for us. So they made this perfect square trinomial before it's been factored. They made this match the formula. So the formula is a squared plus 2 times a times b plus b squared. So they figured out that a would have to be x in order for x to be squared to make x squared. And b would have to be 13 because 13 squared would give you 169. The middle, which is 2 times a times b, which we found to be x and 13, would equal that 26x. And then from there, after you've matched the formula, you can simplify into what it shows up in the top. So we're going to try it with example 2. We have 9x squared minus 24x plus 16. So first, I need to figure out what is a. Well, I know that this term is a squared. So to get back to what it was originally, I have to take the square root. So the square root of 9 is 3, and the square root of x squared is x. Now my a value goes in front and also goes in the middle blank, because we have 2 times a. So if a is 3x, because 3x squared gives you 9x squared, then it has to go in the middle term as well. To get the other missing part, that b value, we have to work backwards. Right now we're given b squared, which equals 16. So we have to work backwards. So the square root of 16 is 4. And that goes in the back as well as in the middle. So in the middle, 2 times 3x times 4 would give me that 24x, so I know that I have my a and my b correct. To finish off my answer, it is a, which is 3x, the minus sign, which is listed here from my original problem and follows through, minus b. b, which is 4, and then the whole thing is squared. And again, we ghosted that formula for you. We gave you parts of it, but that comes from the formula chart. So if you can match it to be a squared minus 2ab plus b squared, then you can simplify it to this very quickly. The other special type that we could have is a difference of two squares. 9x squared minus 36 is a difference of two squares because it's subtraction, and both of the terms can be square rooted quickly. Also, if you notice, this has no middle term of an x. So we take the square root of both terms. 9x squared, the square root would be 3x, just like it was on the left side. The square root of 9 is 3. The square root of x squared is x. I also take the square root of 36 to get 6. My answer, like they tell us in the formula, is a, which is 3x. And then we make one negative and one positive. And then plus or minus b. b is 6, so 6 goes in the other parts of my blanks. And this whole thing would be my answer. So 3x minus 6 and 3x plus 6. Now, the thing with the special cases is they give you the formulas for them. However, you can also use the box on every single special case as long as you're able to recognize that if you get an answer like this, it is a perfect square trinomial. The bottom part, we have x squared plus 18 is not a difference of two squares because of two reasons. The first is the plus sign. You can't have a difference of two squares if you have a plus sign. Also, the square root of 18 is not a nice number. So it's not a squared number. There's not a number you could multiply or square by itself to get 18. So it doesn't have the difference and it doesn't have the square, so it's not a difference of squares. So on the bottom, this part has already been done for you. You do need to change this piece right here because when the person factored it, they did not factor correctly out the GCF. So remember when we factor, this is just a reminder of how to factor normally. You put your first term and your last term in the box. You multiply them together for your product, so your product is 6x squared. Your sum is the number not listed in the box. We put the product in y equals and search for the sum. Once we do that, we find the numbers -1 and -6, so we put those in our boxes with an x. From there, we take out our GCFs. So 3x squared and -6x share a 3 as well as an x. -1x and 2 share a -1. 3x squared and -1x share an x. -6x and 2 share a -2. So my answer down at the bottom is going to be the two factors listed on the top and on the side. So 3x minus 1 and x minus 2. Remember that you can do a quick check by taking this number times this number and seeing if you get that number, and this number times this number to see if you get that number. For this other option that has not been finished for us, the first thing we have to do is be careful when we start with our leading term as a negative. Because of the way we use the box, we're going to have to factor out a GCF of -1 first to see what we're really working with in our box. So remember, when we factor out a GCF, you take out that -1 and you divide it out. Whatever is left goes in parentheses. Remember that negative divided by negative cancels. If you divide by a negative and don't already have a negative, it changes the sign. So all of these signs have changed. So in my box, I put my first term and my last term. I multiply those for my product of -20 m squared. My sum is the part not listed in my box, and remember we're only using the parentheses. So my sum is the 8m. I'm now looking for two numbers to put in these two boxes that will multiply to a -20 but add to a -8. So in y equals, I put my product of -20 and divide it by x to give me or list out all of the factors. I then click second table, and I am looking only at whole numbers, and I'm only looking for two numbers that will add to 8. So 1 plus -20 is -19, which is not 8. 2 plus -10 is a -8, but we need a +8. That's a decimal, so I skip it. 4 plus -5 is -1. 5 plus -4 is +1. Skip decimals. 10 plus -2 would get me a +8. So in my box, I fill in the two numbers exactly like I see them, 10 and -2, and I make sure to put that m on it because if I don't, 10 minus 2 is only 8, not 8m. From here, I factor out my GCFs. So I work vertically first. 4m squared and negative 2m share a 2 as well as an m. 10m and negative 5 share a 5, and that 5 is positive because this term is positive. 4m squared and 10m share a 2 as well as an m. Negative 2m and negative 5 share a negative 1. So my final answer is the negative 1 that I factored out, my top factor, and my bottom factor. Remember that your answers, the order does not matter, so if you put 2m minus 1 here and 2m plus 5 here, that's okay, as long as you don't mix the 2m's together and the 5's and the negative 1. If you put 2m minus 5 and 2m plus 1, that would be a problem. Also, don't forget to include your GCF back in your answer, which is something that I forgot to do in class the other day. Next in this reporting category, we move on to functions. Functions are fun because you only have to look at one tiny little piece to decide yes or no. So a function is a set of ordered pairs in which no x values repeat. So your x's cannot repeat. If any of your x values repeat, that is a problem. We can think about this like a normal relationship. If people break up, but then keep going back to each other, so the x's keep getting back together, that's a problem, and it's not a good, functioning, healthy relationship. It's not good for either person involved. In the same way, our functions, we just look at our x values. In this first example, our x values are underlined for us, so remember ordered pairs are always alphabetical, x comma y. So with functions, we're just looking at that first part. And if my first parts aren't changing or are all different, then we're good to go. It's a function. So when we look at our second example, our x values are 1, 2, 3, 4, and 5. None of those numbers are repeated, so this is a function. As we can see from this example, the y values don't matter. Your y values could be exactly the same the whole way through, but it's your x values that we're looking at. On the last example, my x's are 0, 0, 1, and 1. This has two sets of repeats, so it is not a function. However, the amount of repeats does not change as long as you have one or more that are repeating, but at least one that repeats. It is not a function. So down at the bottom, we have some more functions to look at. If we're given a table, we're just looking at the x values. My x values are 0, 1, 2, 3, and 4. None of them repeat, so it is a function. On my points, looking at the x's, 3, 7, 10, and 10. Because 10 repeats, it is not a function. Next, let's go over here and look at the vertical line test. Remember, the word vertical means straight up and down. It is important in basketball, if players want to be good, that they have a good vertical. That means they can jump up to the basket. It doesn't help them to be able to jump across the court because most of the time they're going to jump out of bounds, and that doesn't help the team. So when you're looking at a vertical line test, vertical lines go up and down. Remember, your x's cannot repeat, meaning that if you draw a line through a function, the line cannot hit more than one time. Your function is the part that has been drawn. We do not include the axes or any of the grid lines. It is only the part that has changed, so that sideways U is what we're looking at, trying to determine if it is a function or not. And because this vertical line hits the function in two places, it means that x has two y's that go with it, and that's a problem. And so this is not a function. On the second part, we can draw a couple different vertical lines, and all of them only touch the function one time. So therefore, it is a function. You need to be careful with the way you draw your lines. You need to make sure they are straight up and down, but you also need to make sure that they are not, that you draw a couple different ones, because if you draw one, like on this graph, this only touches one time. So that would look like a function, but if you keep going, you can see it's not a function. So if you're given a graph, you need to try a couple different lines just to see. So now let's look at the verbal. On the verbal parts, we're looking at the number of floors in a hotel versus the height of the hotel. So we're trying to determine if this is or is not a function. So we have different floors, floor 1, floor 2, floor 3, floor 4. And let's say when you're on floor 1, you haven't gone anywhere. It's ground level. Floor 2, you go up 5 feet. Floor 3, you go up 10. And maybe floor 4 is at 15. I'm just completely making these numbers up. Remember, we only look at our x values. Can you be on 2 floors at the same time? Can you be on floor 1 and floor 2 at the same time? No. And be careful, we're talking about normal hotels, not slanted crazy hotels. So these, you can't do it, you can't have repeating floors. So this would be a function. It would be a really bad hotel to have like 3 floor 1s, because then it'd be really confusing, and most of the time they do like basement level, floor 1, lobby. They name them different things so that you know where you're going in the elevator. When we talk about students, each student in your school versus their age, I can ask 5 different students their ages, and maybe they tell me they're 14, 15, 17, 16, and 14. And again, I'm just making these numbers up. But if I ask 5 different students and I don't repeat any students, none of my x values are repeating, so it would be a function. And again, these numbers are just coming from being made up, but it's to help you see that none of your x values are repeating, and that's what's important if things are to be a function. So lastly, we have some different types of equations or ways that we could see functions to be asked if they are functions. So x equals -3, we have to remind ourselves, is this a VUX or a HOI? Now this one's going to be a VUX because it has the letter x. Remember, VUX stands for vertical, undefined, and x equals. So we have an x equals, meaning it is a vertical, undefined line. -3 is somewhere on the left side, so if we draw just a rough sketch, that's about what my graph would look like. Now if I complete the vertical line test, my vertical line is going to hit at all of these different places. It's going to hit every single one, which means all of your x values repeat. So x equals are not functions. None of them will ever be a function because of the way that they are drawn and what they represent. It means that all of your x values are -3, so all of your x values are exactly the same. On the bottom, we're given a mapping. Remember that with mapping, your x's map to your y's, and so if you have a -4 going here, -2 going here, 0 going here, and 3 going here, none of your x values have repeated, so it is a function. Now, if you had 2 arrows coming from the same x value, that would not be a function. That would be a problem, but we don't have that, so this is a function. So when we continue these functions, a graph shows a function if and only if it passes the vertical line test. That means that it passes through the graph only one time. So we have this example that's been done for us. If we complete the vertical line test 4 times, all of them pass. So over here, this passes, that passes, but this one hits 2 times, meaning that that one spot makes it a not function. So you have to make sure that you really try and be very careful where you draw your vertical lines and try a couple of different ones, because the first 2 lines on this graph passed, but the last one did not. So you need to make sure that you're trying a couple of different lines. On this graph, all 3 of the lines that I drew pass. There's nowhere that my x's are repeated, so this is a function. This one has already been done for us. The blue line has been drawn on top of the right facing V, and it is not a function because the vertical line hits or touches 2 times. We can represent x and y's in a couple of different ways. X can be domain, input and independent. Y can be range, output and dependent. And we've given you Dr. XY wears his ID in the office to help you remember that. The independent variable is your input, which is always inside the equation. Remember that the word variable means letter. So the letter, that's the input or your independent letter, is always inside the equation. So here, my x is inside, so that's going to be my independent variable, where my y is outside by itself, so that would be the dependent variable. And as we've reminded you, Dr. XY wears his ID in the office, your x is always independent and y is always dependent. So on this next page, we're looking at evaluating functions, not determining if it is a function, but being told, yes, it's a function, do something with it. So we have 2 options. We can either substitute x into the equation, or what I think is the easiest option, which is option 2, put the equation into y equals and check your table. That is usually the easiest option for us. So for the first example that's been done for you, I would put this entire function into y equals exactly like I see it, 3x minus 2. Remember, x always goes inside, so when they give you a 3 inside the parentheses, they're telling you x is 3. So I click second graph to check my table. When x is 3, y is 7, and that's the answer they're looking for. So we're going to do this one together. In y equals, I'm typing x squared plus 3x minus 4. So I'm putting my entire equation into y equals. They are giving me an x value, so when I click second graph, I go to that x value and find my y. When x is negative 2, y is negative 6, and that's the answer they are looking for. So for the last example, we have the function negative 3 parentheses 5 close parentheses raised to the x. I'm typing the function exactly like I see it. They again have given me a letter inside the parentheses, inside independent x value. So I'm going to click second graph and go to where x is 3. When x is 3, y is negative 375. So on these top 3, you're given an equation and you're given an x, so you use x to go find y. All you need to do is put those equations or those functions exactly like you see them into y equals and use your table. Let the calculator do the hard work for you. Now, in this middle section, they ask what value of x would make the following functions true. If they're asking you for x, it means they're not giving you x, meaning they're giving you your y value. So we're going to follow some of the same steps. I'm going to put my function exactly like I see it into y equals, so I'm looking at 3x minus 2. I'm going to click second graph to go to my table, but this time I'm looking for a y value, so I look on this side. When y is 19, x is 7. So I'm following the same steps, I'm just looking in a slightly different place. For the second example, I have the function x squared plus 3x minus 4. So I plug that in exactly like I see it. Again, they're giving me a 0 on the y, so here's one, it popped up right there. When y is 0, x is 1. If you notice, there's 2 answers remaining there's 1 answer remaining. There's 2 answers shown because this is a quadratic, which means when it crosses 0, it's going to hit 2 times. So I have to keep searching. Oh, there it is. When y is 0, x is -4. So you need to look at the answer choices that you are given. If there's ever a time where they give you two answers, like 1 and -4 or 2 points, then you need to make sure you check both of them, because you will not be counted right if you get one but not the other. Down at the bottom, we're given some literal equations and we're asked to solve. The hard part for us about literal equations is that there's less things that we can actually do. We follow very similar steps, but we can't actually complete, or maybe sometimes we get kind of confused in where things go because they don't get combined, so it's kind of confusing for us. So whatever we are solving for, box that. Move anything that's not in your box to the other side through the opposite operation. So 3x and 3 got moved through subtraction. 3x and 3, or -3x and -3, are not like terms, so they get rewritten, and we have the -2y on the left side. Now, still looking for y, so I divide everything by -2. Negatives cancel. I can't simplify those fractions anymore, so that's what I'm left with. For this example, they ask us to solve for b. So 1/2 and h are both attached to b, so I need to divide, and that's already been shown for us. Once you divide, they cancel out, so I'm left with a b on the right side, and a divided by 1/2 h on the left side. A and h are different letters. They do not mesh together. I cannot put them together. I cannot divide them. I cannot do anything with them, so I simply leave it. You could also see your answer as 2a divided by h, because they might try to make that 1/2 nice, but I wouldn't worry about that. For the last one here, they ask us for w in terms of x and y. So they're asking us to solve for w. So I boxed the 2w and I moved the 2y to the other side, because the 2y is on the same side but not in my box. So the box comes down. On the right side, x minus 2y, those are not like terms, they're not the same letter. I cannot combine them, so I simply rewrite them. My last step is to get w completely by itself. There's a 2 attached through multiplication, so I divide everything by 2. There's two ways you can write your answer. The first is to leave it like you see it, or to divide each piece by 2. X divided by 2 is just x divided by 2. -2y divided by 2, my 2's would cancel, and so I'd be left with -y. It is up to you how you want to write this, because you could see both of these on an EOC, so make sure you recognize how they got to both sets of answers. The last piece in this reporting category is something we just went over in Unit 16 through regressions. If you're given a list of numbers, set them up in a table and use your stat edit. And so these have been set up for us, but you just put number 1, number 2, number 3, number 4. I've already put this in my calculator, so if you want to pause and put it in too, now is the time to pause the video. So number order, numbers that are actually listed. We notice all of our answer choices are LinRegs. So I go to option 4, and my answer has to be C. Notice it's kind of hard to see, but in here these had negative signs, and they were crossed out because y is not decreasing. However, if you just use your stat edit, that's a way to get through two answer choices, but stat edit will give you the correct answer as well.